Okay, so let's suppose we have a function 2x squared minus x plus 3. Now we know from experience that this is a parabola concave up. And suppose I want to know what some of the y values are for particular x values. Well, if we have f of x is equal to that function, and let's say I wanted to know what is f of 4. If x is equal to 4, what's the y value on that parabola? So let's see. I could just plug 4 straight in, right? We could just say, okay, 2 times 4 to the power of 2 minus 4 plus 3. And you know, we solved this earlier, right, in the slide. But just, you know, as a review here, let's do it again. 4 squared is 16, and 16 times 2 is 32. And then 32 plus 3 is 35, and 35 minus 4 is 31. So what does that tell me? Now, this is not going to be drawn to scale. This is just to illustrate a point here. If I have a parabola, now let's say this is a graph of the function, I now know that when x is 4, the y value is 31. Now, this is a fairly simple function. It's not too complicated. We've done these before. Let me go back and try to clean this up just a little bit. But if we had something a lot more complicated, there's another method for figuring out the y value besides substitution, and that's called synthetic division. We've done that before. And we will put the 4 in the box, and I will put my coefficients over here to the left. And of course, I'm going to check to make sure I have no gaps, right? Because sometimes we have to use a 0, right, as a placeholder. So let's double check that. I have a power of 2 column, a power of 1 column, and a constant column. So it looks like we're good. And remember to start this process, right? We bring down the leading coefficient. So I will bring the 2 down, and then I'll multiply. 4 times 2 gives me 8. And if I add that column, I get a 7. And then 4 times 7 is 28. So that would go here. And then if I add this column, 28 plus 3 gives me 31. Notice that my remainder, right, is 31. And it also happens to be the y value when x is 4. What if I wanted to know the y value when x is equal to 2? Okay, same thing. I could plug 2 straight into the function and solve. But again, let's try this using synthetic division. I'll put 2 in the box. I will write the coefficients again, 2, -1, 3. And let's go through the process. I'll bring the 2 down, multiply, add, multiply again, and add. So I now know that when x is equal to 2 on that parabola, the y value is 9. So I'll just put it here. And let's just do one more. What if x happens to be -1? Well, same thing. If I want to know the y value when x is -1, I'll just go through the synthetic division process again, looking at the remainder, and we'll know the y value. So we have 1 times, let's see, -1 times +2 is -2. If I add that column, I get a -3. And -1 times -3 is +3, so I end up getting a 6 for the remainder. I went a little quickly, so let's make sure I'm correct. -1 Then I will say 2, negative 1, 3. I bring the 2 down. Multiply, that gives me negative 3, positive 3, 6. So yes, if we have negative 1, if x is negative 1, let's say at that point on the parabola, I now know that the y value is 6. So that's how the remainder theorem works. The remainder gives you the y value for this x value.